This is a Chevy Volt first generation onboard battery charger. General Motors made the Chevy Volt for about 10 years from 2010 until 2019. About halfway through that time period, they switched the design and went to a different charger in 2016. We'll focus on the first generation charger and its hardware in this video. And these are all its tentacles. I think I'm going to split this video series into two. The first part will focus on the hardware and how to connect everything, and in the second part we'll talk about the software and how to control it. I want to share with you what I've learned about this charger and how I grew to like it. As you can see, this charger has connections on both sides. There's the high voltage side and the low voltage side. I want to talk about the high voltage side first. This is also divided in two. On one side we have the high voltage AC input. So let's talk about that for a second. I like to go out and buy all the original cables for whichever EV conversion device I purchase. If I end up using them, great. If not, I discover for myself why I couldn't use them. Sometimes I can use them in their original state, and sometimes I have to modify them. So in this case, I went out and I bought the cable that runs from the charger to the socket, the charging socket. Okay. So on one side, it plugs into here. By the way, these two connectors are not interchangeable by design. You could see that one had three what I call nostrils in it, the other one two ports, but they also are keyed differently on the sides here. Anyway, I went out and I purchased this cable and to connect it to this socket, and I bought this socket, and then I went even as far as buying the J1772 standard wall charger here. This is an actual Voltec GM Chevy Volt wall charger. I bought it used on eBay. And when I went to set this up and test, I actually learned my first lesson, and that is that this actually makes things more difficult, especially for us noobs, because this will not charge, it will not really turn on and send electricity to the charger outside of the Volt. It has two extra wires in here that are currently not connected to anything, and it takes some doing to figure these out and set them up. That's sort of outside of the scope of this video. I may make an additional video going over that. But rather than figuring this stuff out and adding to the complexity, I just decided to go to Home Depot and buy myself a regular 120 volt 15 amp plug and put it on here. So I ended up cutting off the end. Because I don't need it. This used to be on this cable, so I just cut it off, put a plug on here. I'm going to bag and tag this, and if I need it later, I'll do something with it or not. But for now, I'm going to put this away. So that is not how we're going to charge, okay? We're going to keep things really simple, really basic, and we're going to use a regular dime a dozen. They're all over every home in the United States, 120 volt, 15 amp, sometimes called 110, whatever, outlets, and that's how we're going to get our AC input, AC power. I also went out and bought another one of these cables, new this time. I found it for only $65, and I will cut the end of that one and put a dryer plug on it, a 3-prong plug for 240 volts, call it 220, 30 amps. So then I can charge either way, either the 110 or the 120. I think this is level 1 and the other one may be level 2. Okay, so this is going to be our input. Now let's talk about the high voltage output. So on the high voltage output side, this ran from the charger, which lives in the front of the vault on the passenger side by the headlight in the very front corner. In accidents, these are notorious for getting knocked out. And the cable that runs from the charger to the battery, high voltage cable, is encased in this aluminum tubing. It's impossible to get it out of there. I actually took one of these apart, and they're crimped on there so permanently that you have to cut this cable. So I just cut it in half and carefully pulled it out of this tubing. If you find a way to use it in its original shape, then good for you. I think if you try to bend this tubing, once it's already been pre-bent to a certain size, you'll just kink it and you risk cutting through this cable. So, tubing not needed. Now I think you can buy one cable and split the costs with a buddy and send him one half of it if you find that half of will be long enough. So I actually don't need half of this. I think the connectors are identical on both sides. They are keyed the same. Okay, so now with this connector cut, the first thing I did is I tried using Anderson connectors. I always wanted to try them. So what I went out and I purchased the 120 series. They have three different levels. There's a 75, 120, and I think maybe a 175. These model naming conventions may parallel their amp ratings. So this is a 120 amp. We don't need that much for charging. We're not going to be going over, 15, 20 amps. But I had to pick this size because of the power poles in them. So inside of these connectors, and there is no right one or left one, they're both identical. There is no positive, negative. These two are identical, and yet they will clip into each other. It's kind of a brilliant design. These are the power poles I speak of. And the challenge was finding a connector that could be small enough on one side to accommodate these cables. So I think the smallest I could use was a 6 gauge on this side. And I'm using, I believe, a 2 gauge on the battery side. This is a cable from my BMW 530e plug-in hybrid. It's a rather proprietary design. There's actually 2 cables inside of each one of these conduits. They came with these unobtainium orange connectors, keyed certain ways on both ends. I decided to cut them off on one end and basically sacrifice a cable. I don't think I'm going to be using Anderson connections in my vehicle. These are just for testing purposes, as I always say. So the bigger poles go on the battery side, but that just means the opening here. The ends are identical, whether it's a 8 gauge or 0 gauge. And then this will simply snap in. And now we have our high voltage AC input and our high voltage DC output. Also on the output side, on the DC side, I like to use a Busman fuse block with a 20 amp fuse. This is an SPF 20 fuse, and I like these fuse blocks because they are screw-in type. These are actually dual. There's a blade for a blade connector, and then there's screws for ring terminals. So I prefer to use the ring terminals. I think that's a sturdier, safer connection. Not a big fan of these plasticky covers. They do have a fault LED in them. That's great. But they remind me of old CD cases where the ends, the flimsy ends, always broke. So I call these like glass covers, even though this is plastic. But they're sort of flimsy. I don't know if I'm going to use this in my actual vehicle, but for testing, as I always say, for testing purposes, this is what we're using. But you do want to protect your charger with a fuse of some sorts. Use a 10 amp, 20, 30, but use something in there. Okay, so that is the high voltage connection. Okay, that's the high voltage side. High voltage AC coming in, high voltage DC going out to the battery. Okay, let's flip this guy over and let's talk about the low voltage side. So we have 2 connections on the low voltage side, and I want to share something that I learned. The second thing I learned about this charger and what I think makes it really great. In addition to charging the high voltage battery, this actually also charges the regular car battery, because this is 2 chargers in one. So again, I like to go out and always buy a pigtail or buy the proper wiring harness, and this is no different. I went out and purchased the actual factory connections for this side, and I also like to unwrap all of my connections to see what's inside the conduit. So once I unwrapped it, I could clearly see that there's rather thick wires. I would call these medium-size wires. No need to get technical and talk about gauges. But this tells me that this is going to carry a bit of amps. Okay? And these just go to the battery. I think technically the red connects to the positive and the black actually goes to the chassis ground. But yes, this side here is output, and it is low voltage output to the battery to charge. Now, obviously there's a connection made there, so it also gets the ground, I think, from this connection. But yes, this charger can charge a regular car battery, and this is the connection that does that. Which brings us to the other side. Now here, on this side, this is what I call communication, or the communication connection. So once again, I went out and I bought the pigtail for the connection, communication connection, okay? And once again, I unwrap it, and then using pinout diagrams that you can find on the internet, I'll post links in the description, we can identify what these wires are. It just so happens that two strands were intertwined or twisted pair. I think I inadvertently unwrapped one, so let me wrap it back up here. So when it's twisted like this, that's usually a dead giveaway that this is CAN bus. This is communication using CAN, and CAN uses two wires. There's CAN high and CAN low signal. So because there's two connections here, I don't know if this is some sort of pass-through like a daisy chain, or it's actually two CAN channels, if you will, but or buses, but one is not used and one we will use, and I'll get to that in a later video when we actually talk about controlling these with something like Savvy CAN. So these two, we know what they do. Then there's other three wires that actually I joined together, and these will connect to the battery positive. Let me show you a little. So something that I like to do is, again, fuse all my connections. And this little trick that I use is, this is just a regular blade fuse. This is 10 amps. And what I do is I connect it in line like this, and then connect this with an alligator clip to my battery. And if you're careful, this works great for testing. It's better than no fuse at all. So that goes on the higher amp side, 10 amp fuse. And then I use something like a 1 amp or a 2 amp. In this case, I have a 2 amp, and this will similarly connect with these blade terminals. Just slips on there, and now in line we have a 2 amp fuse, and this will go to the positive. Okay, so there's actually two positive connections there. The ground is through the black wire, and that wraps up the low voltage connections. We'll get to connecting this to a control device in another video.